All right, this is a recording for the second half of the notes for 3-3. We're going to do percentiles and box and whisker plots. And yesterday we talked about percentile and finding a percentile. If you're given the data values, you take the number of people who are less than you are, and then you divide by the total number, or n, right? That just tells you what percent is lower than you. So yesterday we said that 11.8, if that's our data value, there was 20 numbers that were less than us out of a total of 50, which is the 40th percentile. I'm going to change that on your notes, like do something real big. Instead of saying 40%, because percent isn't the same thing as percentile, I want you to do this instead. Change it so that it says 40th percentile, because it's not the same thing as a percent. It's the 40th percentile. So we'll call it that rather than putting the percent symbol behind it. Does that make sense? It's the 40th percentile, not technically 40%. So change that a little bit on there. Okay? Now converting back to a percentile, they are converting back to the data value. Now they're going to be doing the opposite for us. And they're saying find the number that is the 20th percentile. They call it P25. So if they say P25, that just means the 25th percentile. Okay? Those two things mean the same thing. Percentile. Okay? P25 is the same thing as the 25th percentile. We're trying to find what that number is. What that number is, okay? So here's what we need to do. We take, and it's right here, we take that percentile and convert it to a decimal, right? So K divided by 100. We would take 25 divided by 100, which just converts it back to 0.25, right? You could probably do that in your head. Okay, 0.25, and then I multiply by my n, okay? And n is 50. We had 50 numbers from above. So what is 0.25 times 50? 0.25 times 50. 13.5. Okay. All right. At the same time, we do the 25th percentile. You got 12. 12.5? Did I say 13?
Yeah, that was my fault.
12.5. Okay. All right, 12.5. Now we're not done with this problem, but we're going to pause and we're going to go down to example 5 really quick. And I'm going to show you the difference between the two. Here we're trying to find the 40th percentile, which is P40. And P40 is the same thing as the 40th percentile. Okay, we're going to do these both kind of at the same time together, all right? So to do this, we would convert the 40th percentile to a decimal, which you can probably do in your head. You just take 40 divided by 100, which just moves the decimal to make it 0.4. You could probably do that in your head without using a calculator, right? And then we take that number times our n again, which is 50. Okay, 0.4 times 50 is going to be like the 20th number. We just found that, right? The 20th number. Okay? All right, now here's the deal. When you're doing percentiles, there's two rules. If when you do this calculation, you end up with a decimal. If decimal. Here's the decimal. If your number ends up being a decimal, like this 12.5 was, we round up to the next number. Okay, so we're looking for 13, but that means we're looking for the 13th number in our data set. Okay? If your number is a decimal, you round that number up, regardless of whether it rounds up or not. Like if it was 12.1, you would still round up to 13. You always round that number up, and we're going to take the 13th number. So the 13th number in my data set, if we go all the way across, there's 10 numbers going across here, so this would be 11, this would be 12, this would be 13. My 13th number is 7.9. Make sense? Okay? 7.9 is the 13th number, and that's the number I'm looking for. Okay? So if it's a decimal, you round it up to the next one, and you take that number in your data set, the 13th number. Okay? If your number is a whole number, okay, it's a little bit trickier if it's a whole number. You don't round up to the next one. We wouldn't take the 21st number. If it's a whole number, you look at the 20th number. If whole number, you would take the average of the 20th and the 21st number. Okay, since our number was 20, we would take that number and the next number and average them together and get a data value. Does that make sense? So if it's a whole number, it's actually a little bit more work than if it's a decimal number, right? Okay, so the 20th number, let's figure out what the 20th number in our data set is. Okay, 20th number here is like 11, was it 11.6? The 21st number was 11.8, right? Okay, so 20th number is 11.6, 21st number is 11.8. So we would average those together. What's halfway between 11.6 and 11.8? 11.7 is the number that we would use, okay? So those are the two rules. If it's a decimal, you round it up and you take that number. If it's a whole number, you take that number and the one next and you average them together, okay? Whole numbers, you average the two numbers. Decimal number, you round up and just take that number, right? That's how you find the percentile number. Make sense? Ish? Kind of? Okay? All right, this is a little flow chart right here that says those exact things. So like here it says, is L a whole number? Right here. If you look at this flow chart, yes, this is the rule. No, this is the rule. Okay, this is kind of the flow chart for that. But it's going to be one of those two scenarios. Either it's a decimal number or a whole number. Make sense?
So
good?
For the example 5, what's the answer? Just 20?
What?
Just 20 for example 5.
Example 5, the answer is 11.7. That is the
Oh,
20th. That is the 40th percentile number, right? 40th percentile number. Okay. Makes sense? Good-ish? Okay, let's go down to box and whisker plots. I'm just going to skip right down to... yeah, let's talk about these guys. When you're doing box and whisker plots, you have a minimum, you have a maximum, and you have a median, we call this guy. We did this in Algebra 2, okay? You have a min, a max, and a median, which they call the second quartile, okay? The second quartile is the same thing as P50. It's the 50th percentile. It's the one that's right in the middle there, right? Okay? And then you have the first quartile. Q1 is like the median of the first half of the data. And you have the third quartile, which they call Q3, which is the median of the second half. Does this make sense? Have we done this before?
Yeah.
Median of the first half of the data, median of the second half of the data. Okay? All right. Quartile 1. So you're taking, when you're finding these 5, this is called the 5-number summary. When you're finding that 5-number summary, you're taking the median like 3 times. Median of the whole thing, median of the first half, median of the second half, right? Okay? I'm going to go over here real quick, and then I'm going to do like a mini example. Okay? Can I do a mini example? Okay. I'm going to do 4 mini examples, actually. Let's say your data set is the numbers 1, 2, 3, 4, and 5. Okay? Let's say, second example, your data set is 1, 2, 3, 4, 5, and 6. Next one, 1, 2, 3, 4, 5, 6, and 7. And your fourth data set is 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm going to show you how to calculate the median when you're given an even number of numbers, an odd number of numbers, etc. Okay. All right. Good? Yeah, ish. Okay, the minimum for each one of these data sets was 1. These are the mins. Yeah? The mins for each data set is 1. The maximum for each data set is each one of these numbers, right? These are the maxes. Okay? Good? All right, then everything else changes a little bit. Okay, so if I'm doing the median number, the middle number of this first data set, what's the middle number? 3. We have an exact middle number. This is the median, right? Okay? All right, let's do the median for this data set. Exact middle number. 3.5 is my exact middle number, so this is the median again. I'm just going to not label him median, okay? What's the exact middle number of the third data set? 4. Exact middle number of the last data set? 4.5. He doesn't have a middle, so we make the middle. 4.5. Make sense? We know how to find the median. Okay, now here's the tricky part. When you're doing Q1 and Q3, which is the first quartile and the last quartile, okay? These rules get screwed up a lot, okay? In this first data set, a lot of people think the number 2 is my Q1. But The rule is when you're finding the first quartile, if you have the median, you toss the median out and you find the average or the middle of that section to find the median. So the median would actually be 1.5. Does that make sense? If you have an exact middle number, you throw them out to find the Q1. Okay? My Q3, I'm running out of colors here. My Q3 would be the median of that one, which would be 4.5. Okay? If you have a median, you toss it out. Okay? All right, same rule applies with the second data set. My median was 3.5, so I toss him out, and technically he's not a number that's in my data set. So that means I'm still allowed to use 3 when I calculate my median, or when I calculate my Q1. Does that make sense?
Yeah.
These are kind of weird rules. So in this case, my Q1 is 2, right? Okay, my Q3 would be 5. Does that make sense? That's the rules, okay? Here in the third data set, we toss out the 4, so I'm only allowed to do those 3 numbers for my Q1. Q1 is going to be 2. Q1 is going to be 2. Here, my Q1 is going to be, or my Q3 is going to be 6. I should have done that in the other color. Like that. Okay? Does this make sense? The last data set, I toss the 4.5 out, so I'm still allowed to use 4 when I'm finding the median. 2.5 is going to be the median. And here it will be 6.5. Yeah? Does that make sense? Those are my Q1 and Q3. So the median gets tossed out when you're finding Q1 and Q3. Okay? That's the rule. All right. Let's go here to use the Verizon Airport data speeds in table 34 to find the 5-number summary. Holy cow. Okay, we need a minimum. We need a maximum. We need a median. We need a Q1 and we need a Q3. Minimum, maximum, median, Q1, Q3. Okay? All right, I'm going to be scrolling back and forth, kind of. Hopefully I don't make you too dizzy. Okay. Okay, what's the lowest data speed? The minimum of these 50 numbers. 0.8, and the highest is 77.8. 0.8, 77.8. I have 50 numbers. We're not going to do cross, right? 50 numbers is 25 numbers over here and 25 numbers over here, right? And these would be the numbers 1 through 25, and these would be the numbers 26 through 50. And we won't have an exact middle number, so we're going to take the average of the 25th and the 26th number, right? Yeah. Okay, the 25th number, I'm going to scroll and make you dizzy. 25th number is 25, 13.7 and 14.1. That's the 25th and 26th, right? Okay, 13.7, 14.1. 13.7, 14.1. Okay, that's my 25th and 26th number. So my median is going to be 13.9. Okay, makes sense? 13.9 was my median. Okay, now I have to find Q1 and Q3. All right, are we good so far? Okay, I'll pause for a second. Okay. All right, I'm going to scroll back up to my data set and we're going to find Q1 and Q3, but let me erase some junk here. Okay, here's my data set. We have our minimum, we have our maximum, and 9? That was my median, okay? Now, I throw out the median. That's the rule. I throw out the median to find Q1. So that means I'm still allowed to use 13.7 to calculate my Q1. And I do like that range. How many numbers do I have in that first set of data? 20. We still have 25, right? Because we're not throwing out that middle one. Like we're still including 13%. What's half of 25? Like we would have 12 here and 12 here, and then we would have one number in the middle. So the 13th number of the data set would be my Q1, right? There's 10 across the top. 1, 2, 3, 7.9 is my Q1, right? Okay, didn't we calculate 7.9 as my P25 down here?
Yeah.
Because P25 is the same thing as a Q1. Did you know that? Yeah, maybe?
Yeah, 25th. Yeah.
Okay, I said P50 is the same thing as the median. P25 would be the same thing as the Q1. What's Q3 going to be?
75.
P75. So if you want to do it that way also, you can do it that way, right? P25, P75. We said 7.9 was my Q1. Yeah? Okay. All right, going back to my data set. Since I didn't have an exact middle, I'm still allowed to use 14.1. And 77.8 is my range there, so I have 25 numbers. Again, it's going to be the 13th number, okay? So to do this, I'm going to count the 13th number back, right? There's 10 numbers here. This would be 11, 12. The 13th number is 21.5. Did I do that right?
Mm-hmm.
Yeah? That's going to be my Q3 or my 75th percentile. Q3 or 75th percentile. I don't remember what that number was. I just lost it. 21.5. Thank you. You're welcome. 21.5. There you go. Questions about that? That was a lot of information. Scrolling back and forth. P25 is the same thing as Q1. P75 is the same thing as Q3. So you can calculate those if you don't want to like cross and like figure out the number. Okay? Happy with that? Last thing, box and whisker plot. Use the Verizon Airport data speeds to construct a box and whisker plot. Okay? Good?
We're not doing the back page.
What do you mean? Maybe. We'll see. I will stop here. Maybe on Monday we'll do one example and then I'll let you have the rest of the time to work. Constructing a box plot. Okay, we have this information. We're going to construct our box plot. Okay, this drives me crazy when I have my algebra kids construct a box and whisker plot, and they draw the box and whisker plot, and they have like, here's my box and here's my whisker plot, and they label it as like, this guy is 0 and this guy's 100 and this guy is 90, 95, 98. I literally have kids that do that. They're like, oh, it's a box and whisker plot, so there's your stuff. Okay, well, you have to make, like, this tells me this looks like all of my data is symmetric, right? Because the box is in the middle, okay? But it's not symmetric. Look at the numbers, right? You guys can see. This box should be, like, all the way over there, right? Okay, so to fix that, to start with, what I always do is I say, let's make a number line, okay? This is going to be like my ruler across the bottom. And we're going to start at, what's the lowest data speed? My minimum, 0.8. So let's start at 0, sure. And my maximum is 77.8. So let's go to 80 maybe, because that's a really nice number. Halfway through would be 40, right? Then I can do half of that, which is 20, and half of that, which is 60, right? I can just keep doing halvesies all the way through, right? Half of that is 10, half of that is 30, half of that is 50, half of that is 70, right? I just keep doing halves, and then I have everything evenly spaced, right? Okay? Really nice. Really nice. Okay? A box plot can often be used to identify skewness. Yes, unless you do it the retarded way like I just showed you, okay? Okay, whatever, sorry. The bad way, the bad way. Anyway. I knew you were going to catch on to that. As soon as it came out of my mouth, I was like, crap. Anyway, minimum, 0.8. We're going to put a dot right above here, like almost at 0. 77.8, we're going to put a dot almost over here at 80. That's my maximum. And then the other 3 numbers from my 5-number summary are going to tell me where my bars go. Okay? So 7.9 is where my first bar is. So like about there. 13.9 is about maybe there. And 21.5 is about there. And there's my box. And there's my whiskers. Holy crap. What's happening with this? What? There's probably an outlier pulling it that direction, yes. That's what I'm guessing. This is skewed to the
right.
Right. This is right skewed. Ah, I hate that. This is right skewed. Okay. $1 million question. Do you see how this box is separated into 4 quarters? Like this is the first quarter, this is the second quarter, this is like the third quarter, and this is like the 4th quarter of my data.
Sure.
Which data set has the fewest numbers in it?
4, because there's no builder. I don't know, I'm just kidding.
Which data set has the most number of numbers in it?
Probably like 3. This is like, is it a trick question?
It is a trick question. It's a trick question.
I-
Which
Well, they're all
which
the same
data
now.
set? Yeah, which interval has the most number of numbers in it? Right, most number of values in it. These ones are more spread apart right here, but there is still
That's
the
not so
same
bad.
number of values in each data set, right? If there's 50, this would be like 12, 12, 12, and 12 numbers in each data set. But like this would be like the 13th number and the third, whatever, those two, right? There's the same number of numbers in each data set, but what do I know about the 4th like quartile?
They're very spread.
They're very spread apart, right? Okay, this is like a football game, like through and through right here. This is what a football game looks like. This is like the illustration of a football game. All of the quarters of a football game are the same length, right?
It just depends.
If it's a good football game and not like a blowout, right, where you get like running clock at the end. If it's a good football game, which quarter feels like the longest? The 4th quarter, because they're stopping the clock like more frequently, because they're trying to like conserve time. Like this is the Lawrence Nelson football game for us, right? Where like we used every single second of the last quarter, right? Okay. This happens a lot in basketball where they're fouling all the time. So like the last quarter of a basketball game or of a good football game, like takes like an hour long, it feels like. It's crazy. Even though all of them are 12 minutes. 12 minutes, 12 minutes, 12 minutes, 12 minutes. Is that what it is? 12 minutes? Okay. The last quarter feels like it might be longer, right? Okay, this is like what's happening here.
You
Same
can
thing.
Stop the clock.
What?
Stopping the clock doesn't affect,
What do you mean?
like, if it goes out of bounds, you just stop the clock.
Just the
general
time.
You're overcomplicating this.
So like stopping the clock more frequently would make it feel like it's longer. That's why this feels longer. It looks longer. Like the 4th quarter is feeling longer, but it's still only 12 minutes on the clock, right? It's still only 12 minutes on the clock. They're not rewinding the clock and whatever, right? Does that make sense?
Yep.
Yeah, but it feels longer. That's why that edge there is that, okay? All right, we'll stop there, okay? We'll maybe do like one more example on Monday. You should be able to get through most of the problems on the homework assignment, given that information. And there's that. Okay, I'll give you time to work on Monday. Yes?
What time do we get
Give you time to work on Monday. Here we go. I'm gonna stop recording.